Hello YouTubers, doing yet another solar project, which is my grid-tied solar power system for my house. And I thought I'd do a quick review of this system. And this is one of my arrays in the backyard, but if you check out my YouTube channel, Bill's Cool Projects, Bill with apostrophe S, Cool Projects, hit the subscribe button. I have a lot of other solar projects that I did on my RV. I have one on my truck, my Jeep. I have an off-grid well pump YouTube that's pretty interesting. But anyway, I thought I'd do this video on my grid-tied system for the house. And I looked at doing what my neighbors do, and they have a company come in and put up solar arrays. My neighbor spent $35,000 and they're paying monthly payments, and supposedly they're getting a reimbursement from the power company and their electric bill savings, which probably is not going to be quite there. So I didn't want to have to commit to that monthly payment. Also, I've got a couple friends that are real estate agents, and the challenge is when they come and put these systems up on their roofs, and they're obligated to pay that fee. They've had some clients basically say, I'm not buying a house unless you take the system down, because I'm not willing to commit to that money. So there's some serious dollars involved, with some of these solar companies. I know Tesla just bought Solar City a while back here in Colorado, and they do that sort of thing. So anyway, I know enough. I'm an electrical engineer, mechanical engineer, so I figured I'm going to put one together myself. So went down, got some solar panels, and these are the bigger ones than I typically use. Typically use a 3x5. These are almost 4x6 or 3x6. So they put out a lot more power, that sort of thing. Also, didn't want to have to climb up on the roof to do stuff. So I figured, you know what, I have a fabrication shop. If you look at my other YouTubes, I'm building hot rod frames and building hot rods and that sort of thing. So I figured I'm going to get some metal together and then build some stands, that I could put into the ground and just have them accessible without climbing up on the roof and doing stuff. So that's what I did here. So worked really well. I also have another array I'll show you on the side of the house, or on the side of the garage, 11 panels down the side. But these are really convenient, but to get the county to approve it, and once I did a grid-tied system touching utility, you have to have all kind of permits and all that stuff, which I went through all that. I had to have an engineering stamp on these array stands for wind and safety and all that stuff to make sure they're going to be strong enough with wind loads, and did all the calculations and put my engineering stamp on it and took it to the county, and then they approved that part of it. And then I had to go through electrical inspections on how I'm wiring it, which I'll cover more detail in the video, and all the stickers I got to use. So anyway, these are the arrays, and let's take a look at the back, how I built these. So here's the back of the array. Really is not that bad. I'll break it down. It was relatively easy to build. If you have a MIG welder and a cutoff wheel, you could probably build one of these. Pretty simple. So anyway, I'm using a Genco solar panel, and this is a JKM 315. So these are older, from probably a year and a half, 2 years ago, and they're 315 watts a piece. And open collector voltage, they're putting out 37 volts, something like that. And I've got 6 of them. I wired all these in series, so you see all the cables link through the ground. So basically I trenched from the first array to the second one, and then came into the third one. So these are all in series. So the goal is that you want to get the maximum voltage possible, and this is DC voltage, not AC. Maximum amount of DC voltage to get into the inverter, which then converts it to AC and drops it down, so it's much more efficient. And they're all linked together with the MC4 connectors. If you need connectors, just go on eBay and buy some wire and buy some connector ends, and then get yourself a crimp tool. It's pretty straightforward. Plenty of YouTubes on how to do this. And again, more stickers. And you'll see in this video, I got stickers everywhere I had to do. I had to do it from the wires coming down, caution solar circuit, and then I have to have stickers on my disconnects rather, and then another warning sticker here. Anyway, these are in series, and then they go through, I trench the ground, and then they go up into the grid tie inverter inside the garage, and I'll show you that here in a bit. But anyway, what I did is went to the local scrapyard, and I got some steel posts that were left over for some building construction. Bought some of that, concreted them into the ground, and then from there I made some pipe. I think this was old steam pipe, basically from a building that's really good. It's not even rusting or anything. I painted everything hunter green, you know, so it looks cool out in the yard. But I have a piece of pipe here, like a sleeve, and then I welded it onto the post, and I put some gussets in here, part of the engineering thing for wind loads and strength and all that. So it is rock solid. And then I have a smaller piece of tubular steam pipe that comes through the end, goes all the way through that sleeve, and then out the other side, okay? So what I wanted to do is be able to tilt these array different times of the year. I'm in Colorado, so like right now, in the spring, I just tilted them. They're about 45 degrees. In the winter months, November, December, January, I'm flat. I'm almost like vertical, 10 degrees or 15 degrees. And then for the summer months, you know, come May or so, what I'll do is I'll pull these down and put them at probably about 15 degrees, so they're almost flat because the sun's so high overhead. And what I did is I put welded a couple nuts in here with a couple bolts that I could lock it down once I tilt it. And then I drilled a hole and I put these pins in, just pins that I got at Home Depot or one of those places. Drilled it all the way through, so I have holes drilled in different parts of these, you know, the inner tube for my 15 degrees, my 35, or my 80 or so. So basically I just grab it, tilt it, pop the pin into the new hole, go back and forth to whatever I want to set, and when I'm done, then I tighten the bolts down and it locks it down. All right, so the construction on the side, I basically took, this is super strut from Home Depot. It's the stuff that the folks use when they're building buildings to hang stuff down from ceilings, and it's this like U-channel with the perforations in the back, and it's got all these different locations where you can bolt it. So what I did is I took quarter 20 bolts with some stop nuts and washers and drilled the holes in the aluminum frame of the solar panel, and then mounted it there. So I've got 2 up top, 2 down the bottom. And then to mount it to the pipe, I took a piece of, looks like 1-inch angle iron right here, and then took a section that's about probably 2-foot section, and then I took another 5/16 bolt, a little bit heavier, and went into the side of the super strut right there, and that mounts the whole assembly onto the tube. And then for a little bit extra strength, I have my internal weld that I did with my MIG, and then I put a strap brace on here. That's a 1-inch piece of steel, and then I just welded it here at first, and then bent it down, and then welded it at the top, on the top and the bottom. So that gave it a lot of rigidity. So this thing is extremely strong. So again, you're all wired in series. For my local codes, even though they're in series, I should be able to just use one disconnect switch, but the inspector made me use one on each one of the stands. And these are Siemens DC disconnects, and they're about 250 bucks a piece. I've got 3 of them, and then I have another solar array on the side of the garage I'll show you, and that'll be a 4th one. So I got what, $1,000 in just DC disconnects rather, to do this. So the idea is that these are DC disconnects. You can't use the stuff that you see at Home Depot and Lowe's, which are AC disconnects. AC is different than DC. DC has a lot of arcing that can happen when you open and close. So these are special disconnect switches for direct current, DC current, that you have to use on a solar panel. And that's probably why the cost is higher. And this is basically a 30 amp 600 volt DC. So anyway, again, they're wired in series. So I've got about 27 volts off each panel. So if you add that up times 6, that gets you up to 180, 190 volts or something like that DC. And then I trenched, everything's underground, and I had to have inspections for that. And basically I have underground approved cabling that I had to use, that I trenched back, and that's probably maybe 100 feet, something like that, to get back to the grid tie inverter. So anyway, you have to use, you know, ground burial type cable, and I don't recall, I think it's 12 gauge that I used, basically to get back there. So that's it for this. If you have any questions on how I did this, leave it in the comments section, but let's go take a look at my other array on the other side of the garage. The other array that I have, again, I call it solar averaging. So right now this array's in the shade, my other array's in the sun, so it's producing. And then for a good portion of the day, both of them are in full sun. So my grid tie inverter, my Solis is what I use, S-O-L-I-S, that I'll show you inside here in a bit. Basically has two lines that can be brought into it from two solar arrays, and I think the maximum per line is 300 volts DC, and it'll accept 2, and then the maximum wattage is, I think I've got a 7,500 watt maximum capacity that it can generate at 220 volts to put power back into the house and then into the grid for any excess. So anyway, there's 11 panels, and these are also Gencos, but these are a little bit smaller panels, and I think these are 250 watts a piece, and I've got 11 of them down here. So let's walk down the end, and again, these are all in series, just like I did the array out in the field. These are all series because I want to get my voltage up as high as I can, my DC voltage. So 11 times 27 volts or 30 volts, whatever that come to be. It's probably 300 volts DC, something like that. And again, another Siemens DC disconnect that's on the side of the house. And how I mounted these, which is pretty cool. I had this open space, and this is facing south, so it's going to get the sun here in a bit. It generates quite a bit of power. I used the super strut again. And on my pole barn, I have these little screws that, you know, mount the siding down. And I figured I'd want a way to mount this. That way, if I ever had to take the system down, I could replace the screws or the bolts that I've got, you know, lagged into the holes of the existing screws that were installed. And I could put these ones back in again, and you would never know that this whole panel system was mounted on the side of the pole barn. So anyway, the super strut you get from Home Depot, stuff they use from hanging, stuff from ceilings and stuff. They sell at Home Depot these little springy bracket things. And that's pretty much a 1/4 thread that you can thread a bolt into it. So what they do is they snap in, you know, and this is after you have your array mounted to, you know, all your studs where you need to just lay them out on the top. And then I have one down here on the bottom running too, that I could show you, along with some pine needles here. And then after you get that installed all the way across, then you can just put up the solar panel, and then you can get these bent clips on eBay or Amazon, and then that's a 1/4 bolt that tightens into that plate, and the spring holds it up against the edge of this in here, and then you just thread it in and it grips it and clamps it down. They work really good. So these are the end ones that you buy. And then for the middle of the solar panels where they're joining, there's a stainless steel plate that they sell. Again, and get it on eBay or Amazon. Again, with a 1/4 bolt with that springy plate that grabs it. And then you're basically sucking down. And these have like really sharp tips on it that bite into the aluminum. So this thing is like solid on here. So again, the top and the bottom along your super strut. So that was pretty straightforward on how this is put together. and lay it out with a chalk line, or snap a string across the top to get all these lined up so it looks good. So anyway, that's the array on the outside. All right, so now we're walking, and I'm going to show you the AC disconnect that I had to do for NEC codes on the side of the garage. So if the fire department were to show up, basically on the outside of the building, I've got AC disconnect, main solar system, AC disconnect. So if I open this up, you know, I can flip open and shut off the breaker to disconnect that. And saw that on the placard that I have. So let's go inside and look at the other stuff. Inside the garage, and then there's my sub panel. So I got a 40 amp, 220 volt sub panel off the main 200 amp panel on the house that I showed you that was trenched all the way out here. And again, more stickers. It's unbelievable how many stickers I had to have. So now I got a warning sticker. Solar electric circuit breaker is backfed. Dual power supply. Serviced by a photovoltaic system. And then I had to have my operating voltage on here too, as far as NEC. And then when you open it up, I even got more stickers. So there's my main breaker that's coming from the grid tie inverter. And anyway, so that's it. And that's a 15 amp breaker basically that I've got on the 40 amp sub panel. Okay, so let's go take a look at my grid tie inverter. It's made by Solis, S-O-L-I-S. And then also, I guess, tied into a company called Genlong, G-I-N-L-O-N-G. And this is a 5,000 watt. It handles two lines, or two solar arrays coming in, which I showed you earlier. And again, more stickers. Let's see, a warning sticker for something or other, and then an electrical shock hazard, whatever. But anyway, it's got this neat control panel. Also, I could tie in through my app. But the power I'm generating right now, it's partly cloudy out right now. And I'm generating power. Today's the 21st, so on the time. And I'm generating even most of the sun outs, 2,628 watts or so, something like that. So over 2,500 watts that I'm generating. And it's not totally sunny out right now. And if I do this, I can go into my different settings, that sort of thing. Okay. And then if I enter this information settings, I could do that. And you can see right now my first array, I'm generating 311 volts DC. Just dropped down to 210 volts DC to up to 245. So it'll fluctuate a little bit, and I'm doing about 10.9 amps. There's my total generating power that's coming off of both. There's my grid frequency for the power company, because again, I'm grid tied. My total energy over 10 megawatt hours that I've generated. Get this thing going again here. So there's my first array, 311 volts at 4.2 amps. And then there's my second array. I'm generating 206 volts DC at about 10 amps. And then this thing will toggle back and forth. So anyway, it generates a lot of power. Since I put this in, there's literally no maintenance to this at all. I think I squeegeed the solar panels off once, but the rain and snow keep it clean. So very maintenance-free system. My next future plan is probably to replace this and use this elsewhere on my property and go to a Solarc, which is a hybrid inverter. So hybrid means it's grid tied, and then I can also run the inverter and power the house off grid. But when I do that, then I need a battery bank, and some people use forklift, reconditioned forklift battery packs, that sort of thing. There are some AGM batteries out there that are becoming a little bit more cost effective, so maybe do that. So anyway, that's a future investment, but Solarc, I think they're out of Dallas, Texas, makes a really nice unit. So as soon as I save up a little more money, I'll probably replace that. So okay, so let's go take a look at the my main panel for my power. And again, this is my grid-tied solar that I have on the house. And basically I have a 200 amp main panel, and then I trenched all the way over to my garage in the back. It's 250 feet trenched through the ground, and I have a 40 amp sub panel off of the main here, 220 volt 40 amp panel that's in the garage. Okay, so for NEC codes, my whole system has been permitted by the my county that I live in for electrical inspection and all that. And part of the NEC requirements is that you got to have a lot of stickers, which is unbelievable. So I probably have $100 worth of stickers on the system. So anyway, one of the requirements is that I have a placard on my main panel. So in the event the fire department shows up, they could see, or the utility company comes up. In the case I'm part of electrical co-op here in Colorado, and I had to have a placard made. I got this on eBay, made up custom, and it says caution. Guys could read that. And then I have to have, there's my barn in the back that I just showed you 250 feet away, and then I'm showing here's my inverter, and then I have to have an AC disconnect on the outside for NEC requirements. That's National Electric Code. Okay, then the layout, I have a solar array out in the field out there, and basically it has main disconnects and all that, and then I'm showing where it comes into the house, and then I have to have a compass setting on there. All right, so inside the panel, there's my main power disconnect, and then I have my barn. There's my circuit breaker for the barn out in the back, garage, pole barn, whatever. And then when you go grid tied, after I had all my county inspections for safety and electrical and mechanical on the arrays out in the field, basically called up my utility company, and they came in and installed, after they did a test to make sure I had island protection, they disconnected and made sure my inverter shut off within milliseconds, that sort of thing. And there's my net meter that's on the house now. So digital net meter, and the idea is that it's going to measure current coming into the house from the power grid when I need extra power, or if I'm shipping out to the power grid, you know, when I'm generating excess solar power, and that'll go to my neighbors' houses, that sort of thing. And then again, more stickers. All right. So right now, if we look at it, probably can't see that, but I'm sending you know, current out to the power company, out to the power grid right now. All right, so let's talk about the net meter a minute on the house that I showed you earlier, and how it works, and some of the other stuff that might be available out there. But so I thought I'd just shoot a view of Mount Evans here. Amazing snow conditions up there, but the ski resort's been closed for weeks now because of the corona thing going on. But anyway, so let's talk about the net meter. The net meter, basically, it's monitoring, you know, energy flow into the house, or if I'm generating off the solar panel, excess energy from my grid-tied inverter going out into the power grid. So how that works is that if the house loads are, you know, pretty much nothing, I'm going to generate about a half a volt higher than what I'm seeing coming from the grid. It basically pushes the energy out to the power grid, the wattage, that sort of thing. So I'm a half a volt higher, you know, I push out to the power grid. Now, if I turn loads on in the house and it exceeds what I'm generating off my solar, my load is going to drop the voltage down, and when I drop down about a half a volt, with turning on the washer or the dryer, dishwasher, or that sort of thing, and maybe an electric oven that we've got, drops down to half a volt, it's going to use all the energy that I'm producing off the solar. But if it's not enough, then basically I'm going to be then sucking energy off of the power grid through my local co-op that I've got here. and that's kind of how it works. So there are some, and I'll talk about the grid tie inverter here, but the net meter is monitoring current flow in either direction. Also, the 60 cycle hertz, I'll show you on my inverter. I think I already showed you maybe the inverter on the display, the frequency it's monitoring from the power company. So you can see that for firsthand how that works. All right. Anyway, let's take a look at the phone app that I could use to monitor it. And you can see on the bottom they have like this little dongle hanging there that plugs into the bottom, and that connects me to my Wi-Fi, which I have Wi-Fi here in the garage. So all the data, all the history is being uploaded into the Solus database, and then I can access it for my phone app. So let's take a look at that. Okay, as I said earlier, my grid-tied inverter, my Solus, has a Wi-Fi connection onto it, tied into the Wi-Fi, and then that's being uploaded to the internet. And I have an app on my phone that allows me to access the panel and the data and all that good stuff. So right now I'm in partial sun, and I'm generating 2.67 kilowatts, so that's 2,670 watts, 2,670 watts. And about 61% of the total capacity for the day, that sort of thing. So if I tap on it, you're going to see I got a picture of my solar arrays. This is a really cool app that Solus has. And you can see there's my other array. But anyway, right now, again, 2,670 watts I'm generating. My total generation, since I've had the system on for the last couple, probably 2.5 years, is over 10 megawatt hours. So that's like burning a 10 million watt light bulb for an hour. So, and then here's my daily generation. I'm usually doing about, even in the wintertime, or it's March right now, March 21st, and still generating about 9 kilowatt hours per day, which is probably a lot more than an average house would use. And if I go down here, I can actually see, here's my generation for the day. I can go by month, I could go by day, and I could see the peaks where the sun was coming between the clouds and kind of where I'm at right now. And then if I go to the month, I could see what I'm generating per month, per year, and then total, that sort of thing. So that's pretty cool. And if I go to, say, yesterday, let's go to yesterday, March 20th. And you could see it, man, didn't work at all because probably my solar panels had snow on them. And then as it melted, I started peaking, with some sun, that sort of thing. And then the day before is when we had the blizzard. And let's see what we generated there, which is probably nothing. Yeah. So anyway, pretty cool application. But again, this is Solus, and I think they're tied in with Genlong, Ginlong. And then here's my device, my inverter, that sort of thing. Anyway, so it's kind of cool that all this data is being uploaded to the cloud into their database, and then I can access it. And there's no monthly charge for this, for the Solus app on your phone, or the data charges or anything like that. So anyway, hope you enjoyed this video. Please hit the bell for my new videos. Check out all my other solar videos, my hot rod projects, that sort of thing that I do. Ton of videos on YouTube, and hit the subscribe button. And if you have any questions, leave them in the comment field, and have a great day. Thanks.